Ball screws are essential components in many automation systems, translating rotational motion into linear motion. A ball screw assembly consists of a ball screw and a ball nut with recirculating ball bearings. The rolling element design provides a low coefficient of friction, resulting in high mechanical efficiency. Unlike lead screws, ball screws use recirculating ball bearings to minimize friction and maximize efficiency, making them ideal for applications requiring high load capacity and precision. So when it comes to selecting the right ball screw for your application, knowing and understanding your application's requirements is crucial. Here are some helpful steps to ensure you're on the right path. Start by defining the load and velocity requirements. Ball screws can handle high thrust loads upwards of 1,500 kilonewtons and achieve velocities up to 4,500 RPM. Next, determine the life expectancy based on the operational profile. Calculate the assembly life using the dynamic load rating specified for each ball nut. This helps in predicting how long the ball screw will perform effectively. Accuracy and repeatability are critical. Lead accuracy measures how far the ball nut travels per screw turn. Ball screws are available in two tolerance levels, transport or T grade, and positioning, also known as P grade. T grade is most suitable for applications requiring simple translation of a load from one point to another. P grade is suitable for applications requiring knowledge of the absolute position of a load at every point along the stroke without external feedback assemblies. T-grade ball screws tend to be less expensive than P-grade due to their cumulative and linear error, whereas P-grade error is controlled and constrained. Repeatability is a measure of a system's ability to return to a designated location during operation. Impacting repeatability is the free movement between the nut and the screw, known as backlash. Ball screw backlash is largely a function of ball bearing diameter. To measure axial backlash, secure the screw from movement and axially push and pull on the ball nut while measuring its movement with a dial indicator. There are three major types of preload. Single nut oversized ball, 4-point contact, which maintains the smallest package size while maintaining full load capacity. Single nut skip lead, 2-point contact, have the capacity of similar sized single nuts as only half of the ball bearings are loaded in each direction. And double nut adjustable preload, 2-point contact, which uses a compression spring to axially load two ball nuts against each other. This is typically used for positioning applications where repeatability is critical. Preloading eliminates axial clearance, which increases stiffness and improves repeatability. However, it does not affect accuracy. Preloaded ball nuts are available on select Thompson precision screws and cost more due to complexity, additional machining, assembly, and verification. Assess mounting issues carefully. The configuration of the end support and travel distance impact load and speed limitations. Proper alignment with the drive system and load is essential for optimal performance. Fixed ends offer greater column strength and higher critical speed compared to supported ends. A supported end is generally easier to align and install than a fixed end, so installation costs are typically lower. There are 4 fixity options: fixed at both ends, fixed at one end and supported at the other, supported at both ends, or fixed at one end and free at the other. Next, you'll need to decide whether you should use the ball nut in tension or compression mode. Compression loads can cause the screw to bow, while tensile loads stretch the screw axially. Ball screws work best with axial loads only. The screw must carry an axial load that is equal and opposite to the load generated on the ball nut by the motor's torque. Consider vibration and harmonic challenges. Critical speed is the rotary speed that creates harmonic vibrations. Remember that every ball screw has its own rotational speed limit, the point of excessive vibration and harmonics in the screw. The critical speed depends on the end support configuration. Be sure to use the Thompson acceptable speed chart to help determine the critical speed of a particular ball screw system. Explore other design possibilities, such as ball return systems and environmental resilience. Common return types include external return tubes that are typically used in inch screws and are cost-effective and easy to install, maintain, and repair. Internal button return systems that are very compact with no external radial protrusions, creating less noise and vibration. Or internal end cap returns that are used on high lead screws and are also compact with low noise and vibration. Environmental resilience is another factor that could impact ball screw selection. Standard wiper kits are available and protect the assembly from contaminants and contain lubrication. Many options are also available for materials and coatings that withstand different environmental conditions. Understand handling and maintenance requirements. Ball screws must be handled carefully prior to proper installation. Shocks to the ball bearings can damage the bearing races through benelling or cracking. High loads or flexing of the screw can lead to bending. Keep the assembly packaged and lubricated and stored in a clean, dry area because debris and contamination can jam recirculation tracks, and high humidity or rain can cause corrosion. Proper lubrication is vital to ball screw performance in life. Lubricants maintain the low friction advantage of ball screw assemblies by minimizing rolling resistance between balls and grooves and sliding friction between adjacent balls. Maintenance teams should inspect ball screws periodically to avoid downtime and maximize life. Perform checks for metal fragments. Measure lash to verify component wear. Check races for wear, spalling, benelling, and contamination. Ensure the screw is lubricated and free of contamination and corrosion. Verify all connections are tight and check for vibration issues. Noise level should be consistent, and the ball nut travel should be smooth and regular. Finally, take advantage of Thompson's online sizing and selection tools. These resources simplify the design process, providing real-time adjustments, customizations, lead times, pricing, and 3D models. To learn more about Thompson ball screws and make the ideal selection for your application, visit thompsonlinear.com or contact our experienced customer support team.